In this video, you will learn how to calculate for the formal charges. From the last lecture video, we saw two different Lewis structures for this molecule over here. So let's get started again. So in order to draw the Lewis structure, step number one, it is to find out the total number of valence electrons. Okay, so that is oxygen over here has 6, carbon has 4, and hydrogen 2. And because 2 times 1, that is equal to 2. So totally there are 12 valence electrons. The next step is to arrange the atoms. Okay, because there are more than one way of arranging the atoms. Last time, what we have seen is carbon over here, hydrogen over here, hydrogen over here, and we can make double bond linked to the oxygen. This is the first one. The second one is I just switch the position of the oxygen and carbon. So oxygen will be at the center and carbon will be over here. And that is linked to hydrogen and hydrogen. When I check the electrons surrounding the central atom and the other atoms, what I find is this carbon, I have 8 electrons surrounding it. This oxygen, 8 electrons surrounding it. So that is a good Lewis structure. Same here, 8 electrons surrounding the oxygen atom. And also there are 8 electrons surrounding the carbon atom. Okay, the question is, which one is more stable? That's where the formal charge steps in. Formal charge is equal to formal charge that is equal to the number of valence electrons from the free atom. Okay, so and that is valence electron from a free atom. In this case, for carbon, that is 4. As you can see here, carbon is 4, oxygen is 6, and hydrogen is 1. You may need to memorize all this. Okay, and nitrogen, that is 5. Fluorine, that is 7. Okay, and if you like to know how I get those, I can find it from a periodic table. Okay, so for this column, for the halogen, it's always 7 valence electrons. The one next to it, oxygen, Chalcogen column, always 6 valence electrons. Over here, carbon, 4 valence electrons. Okay, so the same column will have the same number of valence electrons. So this is from the periodic table. Okay, so the same family will have the same valence electrons. Okay. Now, let's get back here and try to calculate the formal charge. So the formal charge is equal to, of that atom, is equal to the valence electron from the free atom minus the number of lone pair electrons, number of lone pair electrons, and then minus half times the number of bonding electrons. Okay, let's see how we do that. Okay, so let's look at this carbon over here. This carbon valence electron for the free atom, it is 4, minus number of lone pair electrons. There is no lone pair electrons surrounding this carbon, and therefore minus 0, and then minus half times the number of the binding electrons. There are 1, 2, 3, 4, 5, 6, 7, 8. There are 8 binding electrons. So this way, I will have formal charge that will be equal to 4 minus 4, and that is 0. So formal charge is 0 over here. Let's look at the oxygen over here. Oxygen, the free atom valence electron is 6, minus number of lone pair electrons. There are 1, 2, 3, 4. 4 lone pair electrons, so minus 4, and then minus half times the number of binding electrons. 1, 2, 3, 4, half times 4. So what I can see is 6 minus 4 minus 2, that is equal to 0. And therefore, the formal charge for the oxygen over here, it is 0. Okay, let's do the same thing for the other Lewis structure. Okay, for the oxygen, what is the number for the free atom? Okay, so number of valence electron for the free atoms for oxygen is, I'm working on this oxygen here now. So as for oxygen, it will be oxygen that is 6 minus number of lone pair electrons. There's no lone pair electrons, so minus 0. And then minus half times the binding electrons. There are 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 binding electrons. So that means it is 6 minus 0 minus 4. That is equal to 2. That's a positive 2. Okay, let me look at this one. As for the carbon, for the free atom, the valence electron will be 4. And minus number of lone pair electrons, 1, 2, 3, 4, minus 4. And then minus half times the number of binding electrons, that means 1, 2, 3, 4. It will be 4 minus 4 and then minus 2. That is equal to negative 2. In other words, over here, according to the calculation, oxygen over here, we get positive 2. That's the formal charge. And carbon over here, we get negative 2. That is the formal charge. Okay, now we know how to calculate for the formal charge. How do we use that to determine which structure is more stable? Any number that is close to 0, that will be more stable. Look at over here. It is 0, 0, so it is very stable. Look at over here. It is positive 2 and negative 2. That is not stable. Especially when oxygen is positive 2, that's really not stable. Because oxygen has a high electronegativity. So high oxygen does not prefer to be a positive formal charge. But in any case, if the numbers are closer to 0, then that structure will be more stable. All right, let's try another example. Okay, for this molecule, CH4, that's the methane. Okay, total number of valence electrons will be, for carbon, there are 4. For hydrogen, it would be 4 times 1. So when we add it up, that would be 8 valence electrons. The next step, give a gas structure, and then next, connect them together. Now, let's check for the octet rule. Okay. Octet rule, that means for carbon, there should be 8 electrons surrounding it. 1, 2, 3, 4, 5, 6, 7, 8. That's good. For hydrogen, it doesn't need to follow the octet rule. Hydrogen with 2 electrons surrounding it will be happy. So hydrogen is happy. So this is a good Lewis structure. Let us calculate the formal charge. The formula will be, that will be equal to, let's calculate for the carbon. It will equal to the valence electrons from a free atom. So the number of valence electrons will be equal to 4. And then minus the number of lone pair electrons. There is no lone pair electron surrounding this carbon, so minus 0. And then minus half times the binding electrons. There are 8 binding electrons. 1, 2, 3, 4, 5, 6, 7, 8. So minus half times 8, and that is equal to 0. So the formal charge for carbon is 0. How about for hydrogen? Hydrogen will be number of valence electrons from a free atom, it is 1. And then minus, there is no lone pair electrons, minus half of the binding electrons, 1 minus 1, that is equal to 0. It's the same for all the other hydrogens. Okay, so now we can see 0 everywhere. That means it is stable. Okay, let's try another one. Okay, with ammonia, NH3. Okay, the first step, it is to count the total number of valence electrons. For nitrogen, there are 5. For hydrogen, 3 times 1. So totally we have 8 valence electrons for the molecule. The next step is to guess a structure and then connect it with a single bond. Okay, so how many electrons have we used? There are 3 single bonds. That means we have used 6. So minus 6. So we have 2 valence electron left. Where should we put it? There's only one place, which is to put it here. Okay, so now let's check for the octet rule. For the hydrogen, only have a single bond connected to it, so hydrogen is happy. Let's look at the nitrogen. Nitrogen, there are 1, 2, 3, 4, 5, 6, 7, 8. There are 8 valence electrons surrounding the nitrogen. So nitrogen is happy. It satisfies the octet rule. Okay, so what about the formal charge? Formal charge, that is equal to the number of valence electrons from the free atom of nitrogen. So nitrogen, there are 5, and then minus lone pair electron, 2 lone pair electrons. Okay, not how many pairs, but how many electrons. And then minus half times binding electrons, 1, 2, 3, 4, 5, 6. Okay, so what I get is 5 minus 2 minus 3, that is equal to 0. Okay, so formal charge for nitrogen is equal to 0. If you do the same way for hydrogen, it's going to equal to 0. And yes. Now, let's look at these 2 Lewis structures. If these 2 are given to you, okay, there are lone pair electrons. So compare this one with the one next to it. So lone pair electrons over here, lone pair electrons, lone pair electrons, and lone pair electrons. Okay, so the formal charge is calculated. This one, and over here is -1, 2, and -1. The question is, which one will be more stable? The one on the left side or the one on the right side? Of course, if anything that is closer to 0 will be more stable. See this one, the number is 2, is too far away from 0. So, and therefore, this one is more stable, the one on the left side. And by the way, if the overall net charge, it is 0, that means when you add up the formal charge, it should also be equal to 0. When you add up the formal charge, that is going to be equal to 0.